So in this video we're going to do the integral of secant squared theta, tangent theta with respect to theta, from pi over 6 to pi over 3. Now how are we going to do this integral? On first inspection it looks nailed on for u substitution. The question is, which are we going to pick? Now I'm going to put it to you that we can do either or as our u substitution. So what I'm going to do is I'm going to run both integrals at the same time down the side of my board here. So let's just split everything in half and let's do u equals tangent theta on this side. So if u equals tan theta, that's my substitution. The derivative of tangent theta, secant squared theta. So du is secant squared theta d theta, and then get d theta on its own. D theta equals du over secant squared theta. So that's our first part. And then we need to look at our parameters of integration. So when u equals pi over 3, theta equals pi over 3. Plug that into u equals tangent theta. So u equals tangent pi over 3, in which case u equals root 3. So that's our upper limit. And then let's look at the case when theta equals pi over 6. In this case u equals tangent pi over 6. And tangent of pi over 6 is just a reciprocal of root 3. So 1 over root 3. So that takes care of our parameters, and then we can just plug that into our integral, and we get root 3 to 1 over root 3, and then we got secant squared theta, and tan theta is u, and then d theta just becomes du over secant squared theta, and then they cancel out, and then we're just left with our integral, which is 1 over root 3 from root 3, and then the u du. So that's where we get to there. We'll calculate that value in a moment. Now let's work on the other side where u equals secant theta. So u equals secant theta. Now let's take the derivative of both sides, and then du equals derivative of secant theta is tan theta secant theta d theta. So that takes care of that. And now let's look at our parameters. Theta's pi over 3. So theta equals pi over 3. Then u equals secant of pi over 3, which is the same as 1 over cosine pi over 3. Cosine of pi over 3 is a half. So then this just becomes 2. So that's our upper parameter. Now let's try pi over 6. So pi over 6, same business again. Secant pi over 6, which is 1 over cosine pi over 6. Cosine of pi over 6 is root 3 over 2. So then this becomes 2 over root 3, as it's just our reciprocal. So now our d theta becomes du divided by that, so we can leave that in there. So let's set up our integral. So our parameters, upper one is 2, lower one is 2 over root 3. So that takes care of that. And then let's look at our integrand. Secant squared theta, well that's just u squared. And then tangent theta, let's put that in. And then our d theta becomes du over tan theta. And secant theta. Well, secant theta, I've got no cancellation, but secant theta is our u. So I can put u there. So I'll put a times there so we can see. Now, these can cancel out. And then this u cancels out the squared term. So then our integral is 2 from 2 over root 3 u du. Now, mysteriously, these do not look like the same integrals. But let's clear off the board and then bring these up to the top and let's work out our values. Okay, right, let's do this integral first. Now, the integrands are both the same, So the results of those are both going to give us u squared over 2. So raise the power by 1 divided by new power. So that's fine. Now let's put our parameters of integration to 2 over root 3. And then let's work this out. So where we see a u, we put 2. And here, subtract it when we see a u, we put 2 over root 3. So here we've got 2 squared over 2 minus 2 over root 3 squared divided by 2. So let's just put that like that and just divide the whole thing by 2. So that's legitimately put in place like that one. And then 2 squared over 2, that's 4 over 2, just gives us 2. And then what do we got here? 2 over root 3 squared. So that's going to give us 4 over 3. And then that's all divided by 2. So 4/3 divided by 2 is just 2/3. So 2 minus 2/3, that's just going to give me 4/3. So this one gives us 4/3. So let's put that one there. Now hopefully we get 4/3 out of this one. But we've got different parameters. Let's see what happens. So we've got the same result, u squared over 2. And then we've got root 3 and 1 over root 3 as our parameters. Okay, let's put this in just as we did here. So now we've got root 3 squared over 2. So that's our upper boundary. Now let's look at our lower boundary. So then we've got 1 over root 3 quantity squared divided by 2. So that takes care of that. Now what's 1 over root 3 squared? Well, 1 over root 3 squared is going to give us a third. A third divided by 2 gives us a sixth. So we know that's a sixth. So what have we got here? Root 3 squared, that's just going to give us 3. And then just divide that by 2, we get 3 over 2. So 3 over 2 minus 1 over 6. Let's just make this nice and straightforward. We've got a minus 1, and then that there is a 9. So that equals 8 over 6, which equals 4 over 3. So this one also gives us 4 over 3. And there we go. So two different u substitutions. Didn't look like the same integral at certain stages, but gives us the same answers. So there we go. Nice example on u substitution.